The entire kind of arc of human history has really been defined by how we harness and capture energy. Initially starting with us leveraging things like fire and then later coal and petroleum fuel sources for our energy needs. And really the great opportunity going forward is this idea that we can capture renewable energy sources, store that energy in batteries, and then use that to power our lives.
Advances in battery design over the past few decades have made modern technology possible. But it's not enough. We need better, cheaper, more energy-dense batteries if we're going to make electric cars ubiquitous and save the planet. Now companies are on the verge of battery breakthroughs that could change the world.
The battery industry has been kind of stuck making batteries one way for like 50 years, and we think it's just time for that to change.
A battery looks like a black box, quite literally sometimes. But inside it is a very complex mixture of chemicals. There are 4 components. There are 2 electrodes, cathode and anode. There's a separator, and then there's a liquid electrolyte typically. And the electrolyte's job is to be able to shuttle ions between the 2 electrodes. And that's what charges the battery, and that's what allows the battery to be then discharged and produce power. Among the everyday technologies, batteries are perhaps one of the oldest because batteries were invented even before electricity was invented, which is to say, there was no way to generate electricity until somebody made a battery. And that was back in 1799 by an Italian scientist named Volta. And what he created was actually called a voltaic pile. It wasn't even called a battery back then. And it was called a pile because it was literally a pile of 2 different types of metal, in this case copper and zinc, separated by typically a piece of cardboard that was dipped in vinegar.
To get a feel for how a battery works, we decided to build our own.
I got a copper sheet, I got a couple zinc sheets, I cut them into 1x1 squares, and I also got a coffee filter that I cut into 1-inch squares too.
Right, just to start off, keep a simple aluminum foil at the bottom so that you're able to test whether the battery is working or not. On top you put a copper sheet, and so now you have to dip the coffee filter into a solution of salt and water.
Okay.
Then you put your coffee filter.
Done.
And then you place the zinc sheet on top. You also have a voltmeter, which basically will be able to measure the voltage that this battery will have.
Okay, so we're getting 0.74 volts.
Yeah, that sounds about right.
Yeah.
Now, you can connect a copper cable on either ends, and you could solder that on. Then you can connect it to, say, an LED light, and that should light up.
The more cells you pile on, the higher the voltage. We piled on 10 layers of zinc and copper to see if we could power up an LED light.
So let's test it with an LED light.
Okay, it's the moment of truth here. There we go.
And that's electricity.
Cool.
Batteries have come a long way since the voltaic pile, but they're still made up of the 4 basic components: anode, cathode, separator, and electrolyte. The current state-of-the-art lithium-ion battery is small, light, and relatively powerful, making everything from mobile devices to electric cars possible. But in order to make decarbonization a reality, batteries need to get much, much better.
We are quite far away from the limits of what a battery can do. Among the different things about batteries that still need to be improved is not just the amount of energy they can store, but they also have to do it safely. Batteries also need to be charged more quickly. And finally, batteries still aren't cheap enough. They probably need to be half the price to be able to compete with the gasoline-powered engine.
To accomplish all that, a number of companies are going inside the black box and tinkering with those 4 basic components, hoping to jumpstart the next generation of batteries.
Batteries have a long history of pretty slow improvement, on the order of 4 to 5% a year. I think we're one of the few companies that are actually trying to do something pretty revolutionary in the space.
Harold Rust's company, Enovix, based just south of San Francisco, is making one seemingly small tweak to the lithium-ion battery, replacing the anode, typically made of carbon, with silicon.
So the major advantage of silicon is it has 3 times the energy density of carbon, which it replaces. So that allows you to pack more stuff in your battery and drive up energy density. But silicon, while it's a great anode, suffers from a bunch of problems, the biggest of which is the fact that it expands 300%.
Easy way to think about it is when you're charging a cell, the silicon tends to expand, and when you discharge it, it compresses or contracts.
That's a potentially battery-busting problem, but Enovix claims to have found a solution, a complex method of arranging the battery's components that keeps the silicon under pressure.
This 3D architecture allows us to constrain that expansion in a very uniform way within the cell that allows us to maintain a very long cycle life.
It allows us to basically manage that swelling without any macroscopic growth of the battery.
A silicon anode battery could store about 50% more energy than what's currently on the market, which could mean we'll be seeing lighter electronics with longer battery life in the near future.
We've been actively sampling batteries over the last 2 years to customers. We're sitting in a room now where we're starting to assemble our first production line, and right now we're targeting, first deliveries towards the end of this year. But we're focused on consumer electronics to start. The technology is definitely applicable to larger battery applications like EVs, potentially grid storage, and so that's on our roadmap.
Elsewhere in Silicon Valley, another company is working on an even more ambitious battery design.
We started with the mission of trying to narrow the gap between combustion engine-based vehicles and EVs. And we recognized that the key there was to build a better battery. We could usher in a new era of transportation. 15-minute charge times, better life performance, and even lower costs. Turns out all those problems can be addressed if you just switch from a carbon or carbon silicon anode to a lithium metal anode.
Usually, the lithium in lithium-ion batteries only refers to the molecule shuttling between the cathode and anode. Making the anode itself out of lithium could double the energy density of the battery, a much bigger leap than a silicon anode battery like Enovix's.
We didn't invent the idea of a lithium metal battery. That idea has been around for a very long time, even before lithium-ion, lithium metal batteries were used.
There's just one small problem.
Unfortunately, they're not safe.
So typically inside a battery, the electrolyte is liquid, but a liquid electrolyte for a lithium metal battery causes the lithium metal to degrade and sometimes even short and catch fire. QuantumScape's main goal was to try and replace what is a liquid electrolyte inside the battery with a solid electrolyte.
The problem is that no one has been able to make one that conducts well enough to compete with the liquid. It wasn't clear that even a material existed in nature that could meet these requirements, so we had to explore a wide range of materials, but luckily nature had a material that meets the requirements and our team was able to find it. It's literally a solid material, it's a ceramic material, but it's kind of a very special material because lithium ions can just zip right through it like they're on a highway.
This single pouch cell is all QuantumScape was able to show us of their solid-state battery. Ultimately, they'll stack 100 of these together to make a complete battery pack. The company is still a few years from selling a commercial product, but the performance improvements they're predicting would be revolutionary.
We've shown that we can charge faster. You can get 80% charge in 15 minutes, which is going to be really important if you're on the road trip or if you don't have a garage to plug your car in and charge overnight. You can get longer range by improving the energy density of the battery. What we've said is we're aiming to have cars driving with these cells in 2024. So the next few years will be about increasing the scale of production. We formed a partnership with Volkswagen in 2012, and they've announced that they would partner with us and make a joint venture to commercialize the cells and go into manufacturing together.
We think that with these batteries, you're going to be able to get EVs that compete more effectively with combustion engine-based vehicles. So you get more energy density, you have lower cost and longer life. So our mission right now is to get these batteries on the road, try to really transform the automotive sector, and in the process really make a dent on CO2 emissions.
Companies like QuantumScape and Innovix are imagining a future in which clean, affordable EVs dominate the roads. But the implications go much further than that. Better batteries are key to almost every technology that could slow down climate change.
Batteries are what are known as an enabling technology, which is that you can use a battery to make an impact across different sectors of the economy and across different types of technologies. So currently, our batteries can go in electric cars, but there's still a battery that needs to go in a truck. Then there needs to be a battery that goes in a ship, and then there needs to be a battery that can go in a plane. There are now bigger and bigger batteries being put on the grid that help us increase the amount of renewables we consume. And all those things get a boost with every little innovation that happens in batteries. And so the impact that batteries can have is immense.